Number 6 is another topic in quadratics called completing the square. All right. It is thoroughly explained in the booklet, so you can check it out. But as you know, I like to, get a new viewpoint, a new perspective. Complete the square for each of the following expressions. What does it mean to complete the square? Okay, so I'm going to try to make this as simple as possible. I've already prepared, make some preparations. Right. So the topic is called completing the square. In a nutshell, completing the square means to, all right. And I say, well, okay, let me stop there. So because it's good in the presence of the students for them seeing it live happening. In a nutshell, completing the square. You know what completing the square means in mathematics under the topic of quadratics? It means to transform. Transform. So that's the standard form for quadratic. Ax squared plus bx plus c. It means to transform ax squared plus bx plus c. Do a transformation on ax squared plus bx plus c to a new form of. So after we work a process on ax squared plus bx plus c, our answer going to look like this. Open bracket. Well, a remains a. A will be outside of the bracket. X plus p, close bracket. Now, certain books using p, certain books using h, so you can use any letter there. Let's just use p. X plus p all squared. So I just discover, we just highlight that the square up in there. All squared plus q. So after we do the transformation on ax squared plus bx plus c, it's not going to look like that anymore. It's going to have a outside the bracket and the square outside of the bracket and a plus q. Okay. So all we need to do is to find what is p and q to do that transformation. A going to remain. Whatever a is, a will be outside there. So if a is 1, 1 going to be outside there. But b will disappear and c will disappear, and you're going to get two new numbers. The square, the little 2, will be outside of the bracket up there. How do we do that? From what I'm seeing in the assignment, we are going to do this for the quadratics where a is 1. Because when a is not 1, for example, 2, 3, the process becomes a little bit more complicated. So the examples I see when we look at assignment 6, all the values of a is 1. So this is not going to be difficult. If a is 2, then that's another story by itself. So a is 1, so you can breathe a sigh of relief. So when a is 1, what you do? Step by step, step by step. Keep that thought. Keep that thought, please. Keep that thought. Keep that thought. No, I'm doing the general steps. I'm being general here. I'm just outlining the steps so we can follow it when we go to the example. Right. So step number 1 is to find what is p. P is always half of b. You can go Timbuktu, you can go Japan, you can go Alaska, you can go France, Australia. P is always half of b. when A is 1, when A is 1. Bear in mind that's for when A is 1. Take note. When A is not 1 is a different ballgame for B. Actually, when A is not 1, P is B over 2A. Okay. Right. So let's write B over 2. So that's P. Straight and simple. Always over 2. Second step. Second step. You want to find what is Q. So let's go to Q now. Let's go to Q. We're going to find out what is Q. Okay. Q now is always C minus, I have to be very careful, C minus, open close bracket, B over 2 all squared. Always minus, or P squared if you want to put it that way. C is always, Q is always C minus P squared. So therefore now, Q is always C minus P squared. That's for when A is 1. Simple as that. So P is always B over 2. Always bear that in mind. And Q is always C minus B over 2 squared. But B over 2 is P. So therefore, Q is always C minus P squared. All right. And then you just substitute back into that form. Okay. So step number 3, you're going to have A, whatever A is, well, A will be 1. You know, in this example, A will be 1. And that's what you write for. These are the 3 main steps for completing the square when A is 1.